All right, guys, so here's the deal. You are going to be doing this Desmos today for me. We're going to go through it, give you a little bit of help, a little bit of assistance here. This is something we've already known how to do. We should have no problem showing all our work. I want you to show all of your work on these screens, okay? You're going to add down, and you should have no problem. If you want to give me what x equals here and y, whatever it is, but I want to see all of your work on both of these screens. I don't want it in your notebook. I want to see your work. So it may take a little bit of time to make it neat, but do it so I can actually look through them and see how you're doing and which mistakes are you making, or if you're perfect and you're rocking it. All right. So that's the first question. Actually, I can just keep in here. The next question here, they're both equaling y, so I can literally take this one here. Can't I put this in place of y, right? So my new problem would be 2x. I know it takes time to write it out cleanly. Do your best, all right? But it is possible to give me some work here. I've been having all of my students in my regular class show me their equations on Desmos, okay, and all their skills and what's going on. And then give me a separation bar, go ahead and solve. You know, you move your letters to the left, constants to the right. Get what x equals, plug x back in, you'll get what y equals, okay? Again, figure out what x is. Once you figure out what x is, plug it back here for x, solve it. You can probably do it in your head, and you'll get what y is. I want to see both answers. All right, those are two pretty easy. All right, this one, all of this equals y. Okay, so this chunk is going to go where y is. Well, the nice thing is this is a plus sign. If this was a negative, you would have to distribute the negative into the problem. But since it's not, I'm going to rewrite the bottom. I'm rewriting this equation right here, but instead of putting y, I know what y is. Y is 2x minus 3 according to the top equation, all right? So I'm going to put 2x minus 3 equals 15, okay? Solve for x. Once you solve for x, plug it in here, and you'll get your y, okay? These are all concepts you should know pretty well, all right? Let's go. Next slide. All right, now you have a word problem. I still want to see the work on the screen, okay? This one isn't too crazy. A large pizza at Palanzio's Pizzeria costs $6.80 plus 0.90 for each topping. The cost of a large cheese pizza at Guido's is $7.30 plus 65 cents for each topping. How many toppings need to be added to a large cheese pizza for Palanzio's Pizzeria and Guido's Pizza in order for the pizzas to cost the same, not including tax? All right, let's deal with this one first. Palanzio's, it's $6.80 plus 0.9 for each topping. This is one of these problems, and you're going to have to start recognizing which ones are slope-intercept. It's going to cost your slope-intercept, it automatically costs what, $6.80? And if you're wondering what the y represents, this is the total amount. This is the total amount. So it's going to be $6.80 plus, what is it, 90 cents per topping. So I'm going to put 0.9, which is the same as 90 cents, right? And 6.8 is the same as, 680, okay? And instead of putting x, I'm going to put a t there, okay? Go ahead and do the one for the bottom, the same idea. And then, well, I'll help you. I'll keep you going. I know it may be tough to get all the work in here. Write it small if you can. And then it's going to be plus 730, right? That's the initial cost. And then 65 cents per topping. And then just like the two previous problems, you are going to go ahead and take this chunk, which you know equals y. This all equals y. You're going to put it here. You're going to cross out y, right? And you're going to put all of that here and then solve for t. And that's all it's asking. All it wants to know is how many toppings is it needed for them to be cost the same. Okay? All right, let's go to the next one. This one's the same idea. Notice the function notation. That's why I put this problem in here, that you can realize the function notation. This is function f, which it still represents a y. This is still y equals. And this is function g, which again is still y equals. And you're going to go ahead and do the same kind of idea. You're going to set this equal to this side over here, okay? You're going to plug it in right here and then solve for x, okay? That's all I need. You can just solve for x on this one, all right? That's fine. You don't have to plug it back in to solve for y. I'll give you a break there. This last question, take a look. This is what we've been doing this week with elimination. This is an elimination word problem. So let's take a look at it. At Tam's, which I love Tam's, you can order 2 tacos and 4 burritos for $8.50. At Norm's, you can order 2 tacos and 1 burrito for $5.50. How much is each taco and burrito? Hint, use elimination. If you remember what elimination looks like, wasn't it like x plus y equals a number? Well, you can tell our variables are going to be different. This is what we're going to be doing next week, is more word problems like this too. So first problem, Tam's, is going to be 2 tacos, right, plus, what is it, plus 4 burritos equals $8.50. All right. The next one's going to be what? 2 tacos at Norm's plus 1 burrito equals $5.50. All right. Now, remember how to do this one? I notice my tacos can get crushed to do this right here. And if I multiply that bottom by -1, and then go ahead and solve the rest of this word problem. All right, guys, do the best you can on this. This is due by 2 p.m. today.